are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
Well, thanks for being here, and thanks for having me. It's been fascinating so far. So many good speakers and topics here. I'm excited to be part of it. This seemed like a great place to talk about some of the more bleeding edge aspirational things that we're working on. I am the Director of Innovation at Sherwood Design Engineers. We're a civil engineering firm primarily. We do a lot of work on sustainability and resilience, and we do a lot of planning and infrastructure work, as well as ecological systems and things like that. And we have a lot of fun in our innovation lab, and sometimes we get to talk about things like high performance human ecology, which is really just a mashup, but I hope you'll agree with me that it's appropriate as far as talking about how cities work and the priorities that we make around design, around architecture, around spending, operations and maintenance, and the way we integrate ecology and natural systems with the urban environment. We work on a lot of projects and a lot of project types. I'm going to talk about a couple of these, everything from Hudson Yards. We engineered the landscape lid on top of the largest real estate project in the history of the United States. We're working on, I'm going to show you some things from a 1.2 million square foot Google campus that we're showing down in the lower middle. That's in Mountain View. And we're finding that the kind of work that I'm going to talk about here applies as well to campus systems at UC Berkeley, shown here, but also many other projects across the nation. Some work at Duke, some work at Rice, etc. So really, I'm looking across project types and trying to understand how this narrative fits in. I think, the way that about this for several years is just looking at urbanization and how cities work. And I think it's fundamental to understand that we have not necessarily prioritized the things that we care about now when we've developed the sort of process of urbanization and development. And really simply, it's just fundamental. The surface of the planet generally does a lot of things that we're trying to figure out now. It filters water, it modulates temperature, it creates oxygen, air quality, flood control. For some reason, the collective design and engineering, genius of the human species in creating our own habitat, we literally wipe out most of those processes through the urbanization process. And the cities that we now have, once we build them, before we even move in and occupy them, they overheat and off gas, literally. Overheat by an average of 7 degrees nationwide. And the air quality is already on the downside before we've actually moved in. Zero exaggeration. When we move into and occupy a city, the city literally starts consuming mountains in the form of coal to heat up and evaporate rivers, which it also consumes, literally, to modulate its temperature. And what we're trying to figure out now is if we're running out of those resources and that way of doing things, how can we re-engineer and redesign human habitat using the collective genius of our species to at minimum perform baseline ecosystem services to what it would do before we put a city there. So that's sort of the frame, at least at the highest level, of just trying to look at, okay, base level, can we make a city do what the surface of the planet did before we did anything to it? Air quality, water quality, temperature, all the things I'm talking about. Fundamentally, we work on water a lot as civil engineers, so you have to look at what's going on with infiltration from 50% of the water going into the ground to only 15% in a major city. What that means is water that used to go into the ground over and then move laterally or subsurface over a period of months to years is now flowing over the surface into the river in a period of 12 to 24 hours and extremely exacerbating flooding. And then in the summer, there's no water left to keep basic base flows going, which means we start losing fish species and we don't have water available as a supply. So we're looking at some sort of major changes in the hydrograph that we're trying to repair. We're also looking at big changes in evaporation. And that's a big part of what's causing our cities to overheat, causing a lot of water. So I'll stop there, but I think, any of us could probably go on and on about what's broken about cities. We've kind of been talking about sustainability and how to bring a lot of this back together for quite some time, most of us. We're looking at some pretty innovative things. San Jose, California, in the sort of middle here on the bottom, diagramming some nuisance waters, creating amazing habitat for steelhead and salmon because it's clean, cold, subsurface groundwater being discharged into the river during dry season when base flows are so low that fish are historically dying sometimes. On the lower right, looking at sewer mining. So we're deep into actually trying to increase our water supply by taking sewer out of big pipes instead of putting it in, treating that water in a local or district scale, and then using that water for anything from toilet flushing to irrigation to cooling towers for air conditioning to literally post-filtration and infiltration into the groundwater table to augment summer flows in streams to help habitat. What we're finding is this irrigation can also do a lot to cool down the city without having to use tremendous amounts of energy. There's a reason we have brownouts during heat waves. It's because we use water and electricity to cool ourselves down. We all know that, I think. And so we're looking at going from sort of business as usual in the lower left with annual demands, almost all being municipal for everything, to only using municipal or even only using potable water where it has to be potable. The other, for commercial, the other 60 to 80% can be something other than drinking water. And we're up to about 50,000 people who have been users of our projects who are no longer using drinking water for other purposes, and we're very proud of that. We're also looking at how to do storage in ways that mimics natural process. Once again, we're still kind of in the warm-up here looking at sustainability and maybe we'll move to resilience. These are things that I think everyone who's listening probably already understands to some extent. An advanced version of sustainability, you're storing 8 million gallons at a Google campus in this case of rainwater in large ponds that you've now engineered hydroperiod type for native plants and native species to utilize. Suddenly it's sort of a triple duty: engineering for water supply, landscape architecture for amenity, and ecology for native species and resilience of the biosphere. So to me, that's pretty advanced, and we thought we had kind of arrived at this kind of thinking, applying similar types of things to Hudson Yards deck landscape, creating toolkits. How can we apply these in sort of a thumbnail-y kind of way? How can we communicate these ideas? What are different ways that we can support ecology, different ways that we can support flooding, et cetera, stormwater capture, stormwater conveyance. Hopefully, as design professionals, most of us have experienced this approach. We're now at a point where it's not good enough. So we're finding ourselves sort of wandering around looking at cities and talking to a lot of architects and urban designers. And the general consensus is not sure what else we can do. We've been making buildings better for 20 years and they're awesome. And they are. Buildings have become incredibly efficient. The material cycles, everything from prefab to 3D printing of buildings to sustainable materials, whether it be rammed earth, mass timber, buildings are becoming incredibly sustainable and to some extent resilient. But we still have issues where the city is still underperforming. And I think there's a mentality that it's a little bit of a mystery because everything's gotten so much better. The cities are so much better. We're thinking about better transportation. So as civil engineers, we started asking, what about your site metrics? Do you have urban site performance metrics? How's the city itself performing outside the building? Blank stares, that's put us on an amazing mission to try and understand what are urban site performance engineering metrics? How do we make it work? What do we run into? And the thing that we really have found is that wellness is a huge driver. And we're not the only ones that are going to say that, but I think that we're going to probably show it to you in a slightly different way. Traditional wisdom, I think when we all got into sustainability, we found ourselves saying, for a little bit of extra building cost, capital upfront cost, we can get a big return. It's going to pay itself back and it's going to be amazing. Not wrong. At a certain point, that became an operations and maintenance cost. And we're realizing that operations and maintenance are 10x the cost of the capital initial payment over the life of the building. And that's great. We've been responding to that as an industry. What we're learning, or really what we're incorporating, I think, as an industry now, once again, this is not news to most of you, I hope, but the salaries in a commercial building are 100x the initial capital investment. And so cutting corners in your capital investment, but losing performance from the inhabitants of the building is a catastrophic financial mistake if you have the ability to make that investment up front. And what we're finding is through biophilia, it doesn't matter if you're talking about a school or an office or a home, interactions with nature, cleaner air, normal daylight. Once again, I hope that I'm preaching to the choir, and I think I am. We're all discovering that human wellness, human performance, human productivity turns out to be much more important in the long run than just talking about the building and its sustainability, or even the long-term payback and O&M over the life of the building on the energy and water side, for example. But trying to understand how these things actually feed one another and how it's the same goal is, I think, where we're headed. And I think it's what we're all trying to figure out. And whether that's a purely digital generative algorithm, which I've been very impressed with and also very frustrated with, because people still make decisions about which inputs are prioritized. And so, the computer has a hard time prioritizing the inputs. And so as human beings, we're constantly learning which inputs are important. I've worked on projects that had extremely advanced digital design at the multi-million square foot scale. And out of the 1,200 design iterations that got churned out, none of them prioritized ecological site design metrics or the benefits associated with them because they were clipped out. So the computer can't make those decisions for us. So we have to understand what the priorities should be, and then we can use those generative tools incredibly well once we know what to input or what to prioritize. So we're starting to learn that overheating of cities is costing us a tremendous amount of money. Arizona State is coming up with these numbers of $10 a square meter. And that's for optimizing landscape systems for temperature-based irrigation control. So the irrigation control is not based on plant needs, and it's not even based on soil moisture. It's based on temperature. If it gets hotter, you apply more water, the water evaporates in the landscape across a block or district scale. The more solar radiation you apply to a wet environment, the more cooling actually occurs. Same principle as a cooling tower. More energy evaporates more water in the same amount of time. You get more cooling. Solar radiation actually does that as long as the landscape stays wet. As soon as it dries out, then you start to get heating. But as long as you keep applying moisture to a landscape, the more solar energy, the more cooling effect. So this becomes really interesting because if you have sufficient inexpensive water, then you can basically get a tremendous amount of cooling and evapotranspiration from plants and even damp landscapes of any kind. But if we're using only direct potable reuse, reverse osmosis, desalination, that water is very expensive and it has a high carbon price tag. And what it's encouraging us to do is not irrigate. We are newly looking at some figures, and I'm not making any promises, but the first run that my team made comparing the cost of cooling a district or a city using landscape metrics versus cooling a district or a city building by building using conventional cooling, twice as expensive on the aggregate to cool the city building by building as it is to cool it by making a high performance landscape that lowers the ambient temperature. I can't say that's going to hold. I told my team if they're off by 80%, I'm ecstatic because I'll take a 20% bump. I don't know where those numbers are going to land, but we're continuing to look at that. If we look at resilience factors that are going to affect human beings, environmental are close to the top everywhere. And a lot of these are related to urban heat island, which kills more people than any natural disaster in the United States over the last 30 years. And I can get into that. In Europe, 2003, 30 to 70,000 additional deaths due to heat wave in 2003. Comparing that to some of the biggest war events we've had even, right? This is a bigger threat than hurricanes, earthquakes, tornadoes, flooding, and our cities are artificially hot already, and we can only expect more of that. Conserving water by not irrigating and not adding landscape to our cities is actually probably not even going to work. I mean, it'll probably kill more people, but it's also going to drive resource demands for cooling individual buildings far beyond the resource demands to actually cool the city by using ecology. So trying to figure out how to get ecology back into cities for a performance point of view so that human beings can be healthier. It's all connected. So putting sort of building performance at odds with human wellness is a fool's errand, the way that we're evaluating it at district and city scale from a civil engineering and site engineering, site performance standpoint. So we're starting to integrate these things and understand how incorporating these elements that are shown to improve human health and wellness, as well as human performance. So less sick days, arriving to work earlier, leaving work later, taking shorter lunch breaks, getting more done while at work. These metrics are well executed and well studied. Faster recovery rates in hospitals, better retention and learning in schools. Across the board, this has become a very well-developed area of study, and there are PhDs all over the country working on it. What we're trying to do is trying to understand what kind of engineering performance we can get out of these same features that we can then put into cities and understand, in this case, and really as our model is sort of building 3 scales of human wellness and ecological performance and how they relate to each other. The human scale is individual, and we can start to think about what those are. Experiential, how do you get calming, how do you get better air quality, things that affect each person. The community scale has to do with, you can't really optimize your personal wellness unless you're part of a community that's healthy. And what can we do at community scale? And that could be neighborhood scale. These could be neighborhood resources. We've talked about some of those things as well. Connectivity and pedestrian and bicycle mobility also play in heavily when you get into these community scales. And then moving to using that same logic, can you really have a healthy person or a healthy community if you're not existing in a healthy environment? So looking at how do we have a healthy environment regionally, citywide, How do we have healthy districts within that fabric? And then how do we have access for individuals to optimize their own health and wellness, self-reported happiness, which goes way up in the presence of these features as well. Integrating all these things into an engineering and human health and wellness platform that pays itself back on an employee performance, student performance, patient performance basis. And translating and transferring these things onto actual projects. Super fun, super exciting. Everyone is that we run into ends up being pretty lit up because there's not really a downside. It's just difficult to pull off. And we're in that early stage where you're paying people probably more than you would pay them to do what they already know how to do, to figure out how to integrate some very complicated overlapping benefits. I think I already showed these, so I'll keep moving. And once again, just looking at how we can start to integrate water, air, habitat, and other sort of ecosystem services and environmental processes into a very controlled, very engineered, very predictable urban fabric. It doesn't have to be messy, but it also has to be relatable, and it has to be part of a fantastic and fabulous design. So we love working with amazing designers who can take these sort of toolkits and apply them in ways that people enjoy. So I'm going to land here. This is a study we're doing in San Jose, California, sort of studying what an urban canyon might look like, where we have flooding problems, we have stormwater and water quality problems, we have urban heat island problems that are worse than usual. We also have social issues to deal with. There's a myriad of things going on. Trying to understand if we can contextualize these. There's a unique opportunity right now in San Jose because Silicon Valley is very successful. Some of the biggest companies in the world are moving into San Jose's downtown, and these companies are highly valuing human health and wellness and understand the relationship between nature experience, or at least outdoor experience, environmental experiences. Seeing birds out your office window is part of a whole matrix that has been presented to us by some of these customers as a high value that helps them attract and retain, also helps them achieve and innovate. So we're deep in trying to understand how this all works and looking forward to doing that, hopefully with all of you.